Hello my dear students. In this video, we'll discuss class 8 maths chapter 3 dimensional figures. Very important points for the exam points revision. First we'll see what are faces, vertices and edges. Okay, faces. Each flat part of a solid is called its face. And what is solid? Objects having fixed shape and size and occupying fixed space are called solids. So solids are you have already learned some solids in previous classes like cuboids, cubes, cylinders and cones. We'll also discuss these and pyramids and tetrahedrons also in this chapter. So here solid, one well-known solid is what? Cuboid. So this is cuboid, this line, and if I do this is called cuboid, where this is length, this is breadth and this is height. So these can be any length, breadth and height, there can be any. So what are faces? Each flat part of solid, like this bottom part, this is flat part, this is solid, top part is solid, left and right part solid, front and back part is solid, this is flat. Okay, these flat parts, these are called faces. So how many faces in cuboid? This is 1 2 3 4 and 5 6. So there are 6 faces in cuboid. Now what is vertices? Each corner where 3 faces of a solid meet. Here this 1 2 and 3, these 3 faces na, this face and bottom face, these are meeting at this corner. So this corner is called vertex. Similarly at this point, this and this means back surface, side surface and bottom surface, so these are meeting at this point, so this is called corners. So how many corners? And the corners are called vertices. So this 4 5 6 7 and this is 8. So there are 8 such corners in cuboid. These are called vertices. Okay, plural form of vertex is what? Vertices. So 8 vertices. Now edges. The 2 faces of a solid meet in a line. 2 faces of a solid, like this face, this right face and this front face. So these are meeting at this line. Okay, so this line is called edge. How many edges are there? This 1 2 3 4 5 6 7 8 9 10 11 and 12. So there are 12 such edges. So we'll represent faces by F, vertices by V and edges by E. Now we'll see for different 3D figures, different 3-dimensional figures, how many numbers, how many faces, vertices and edges are there. Now I will show you how many faces, vertices and edges are there in these 3-dimensional figures. We have already seen for cuboid there are 6 faces, 8 vertices, these 8 corners. Okay, these 8 vertices, and number of edges, there are 12 edges, 4 and 4 8 to 10 and to 12. So 12 edges. And what is the difference between cuboid and cube? Already you know that in cube length, breadth and height all are equal. For cuboid it may or may not be equal, but cube it's all are equal, means number of faces, vertices and edges will also be equal. But in the cube case all faces are of square face, and in cuboid all faces are of cuboid face, sorry, rectangle face. Now triangular prism. What is triangular prism? A prism that has 2 end faces, similar end faces, like here this triangular prism means this end faces, these 2 end faces are of triangle face, and then remaining faces are of rectangle face. So this triangular prism has both the end faces are same. So here 2 triangle faces, these 2 triangle faces and this 3 rectangular faces, this one rectangular face from that side if we see. Okay, this is 3D figure, so you can see this is not rectangular, this is parallelogram, but it is rectangular. Similarly this is also rectangular, this is bottom face, and this is front face, this is also rectangular. So total 2 triangular and 3 rectangular. So total 5 faces are there. How many vertices? These 3 and 4, 5, 6. These 6 vertices are there. Number of edges? This 1, 2, 3, 4, 5, 6, 7, 8 and 9. These 9 edges. Similarly for a square pyramid, it was prism. In prism, both the ends faces are same. In pyramid, the top face is the corner point. Okay, so this is square pyramid. Square pyramid means this base is square and this all are meeting at single vertex point at top. So how many faces are there? This one face is the square face and other 4 are rectangular face. Sorry, this triangular face. This one, this triangular, this another triangular, one this back side from here and one this back side from here. So there are 4 triangular faces and 1 square face. So total 5 faces. And number of vertices, this 1, 2, 3, 4 and 5. Number of vertices 5. Number of edges 1, 2, 3, 4, 5, 6, 7 and 8. So 8 edges. Similarly, this rectangular pyramid. If it is square pyramid, the base will be square. If it is rectangular pyramid, base will be rectangular. Means in this case also, this is same. Number of faces total 5. But in this case, this one face will be of rectangular face if it is rectangular pyramid, and 4 are triangular faces. So in pyramid, always faces, other faces are of triangular faces. In prism, other faces are of rectangular faces. So in this case also, rectangular pyramid, number of vertices 5, number of edges 8. Now this last figure, triangular pyramid, we call it tetrahedron also. Triangular pyramid. So this pyramid means this is triangular, this triangle and means this triangle, all are meeting at one place. Okay, one corner. So how many faces are there? There are total 4 faces. This one face, this another face 2, this third, and this is total face, this is front face. So total 4 triangular faces are there. Number of vertices, this 1, 2, 3 and 4, these 4 vertices. And number of edges, this 1, 2, 3, 4, 5 and 6. So there are 6 edges. Now here you have to understand that all the 3D figures follow the Euler's rule, Euler's relation. Euler has given this relation. Euler is given this relation. What is the relation? F plus V is equals to E plus 2. For any solid, number of faces plus number of vertices is equals to number of edges plus 2. That you have to remember. That relation can be written as in equation form like F minus E plus V equals to 2. I have taken this left side, so F minus E plus V equals to 2. That way also I can write, or I can write this F equals to E plus 2 minus V. Anyway, means I can change this equation in that form. Now just check whether these cuboids are following this Euler's formula or not. Check it here. F plus V, faces plus vertices, is edges plus 2. Means we have to add these 6 and 8, 14. Edges 12, 12 plus 2, 14. Means this follows that. So they can ask to prove that, to verify the Euler's relation for any solid. So first you have to draw the solid, write the number of faces, vertices and edges, write Euler's formula, put the value and verify that. Similarly for cube, 8 plus 6, 14, 12 plus 2, 14. Number of edges plus 2 we have to do. Similarly triangular prism, this 5 faces total plus 6 vertices. 5 plus 6, 11. And this is 9 plus 2, 11. Means verifying. Similarly square pyramid, this 5 faces and this 5. So 5 plus 5, 10. 5 faces and 5 vertices, total 10. And this 8 plus 2, edges plus 2 is also 10. This is also verifying this. Rectangular pyramid, similar to square pyramid, this 5 plus 5, 10. 8 plus 2, 10. Means you have to do this E plus 2. And now triangular pyramid, this is also called tetrahedron, that you have to remember, because sometimes they can give this tetrahedron name. So this 4 triangular faces plus 4 vertices, 4 plus 4, 8 and 6 plus 2, that is 8. Means all the solids are verifying this Euler's relation for their faces, vertices and edges. I think it's clear to you. So please just like and share it to your friends and subscribe my channel to get such types of videos. Thanks for watching.